Acid rain is caused by a chemical reaction that begins when compounds like sulfur dioxide and nitrogen oxides are released into the air. These substances can rise very high into the atmosphere, where they mix and react with water, oxygen, and other chemicals to form more acidic pollutants, known as acid rain. Burning fossil fuels, manufacturing, oil refineries, electricity generation, and vehicles all release sulfur and nitrogen oxides into the atmosphere. Acid rain can harm human health by irritating the skin, eyes, and mucous membranes. It can also cause respiratory illnesses, cardiovascular problems, and dental erosion. Acid rain can also harm animals, plants, and the environment. Acid rain can damage buildings and objects. Acid rain can harm forests. Acid rain can damage lakes and streams. Acid rain can harm agriculture by leaching nutrients from the soil and damaging the root system. The ecological effects of acid rain are most clearly seen in the aquatic or water environments, such as streams, lakes, and marshes. Acid rain flows into streams, lakes, and marshes after falling on forests, fields, buildings, and roads. Acid rain also falls directly on aquatic habitats. Most lakes and streams have a pH between 6 and 8, although some lakes are naturally acidic even without the effects of acid rain. Acid rain primarily affects sensitive bodies of water, which are located in watersheds whose soils have a limited ability to neutralize acidic compounds called buffering capacity. Lakes and streams become acidic, i.e., the pH value goes down when the water itself and its surrounding soil cannot buffer the acid rain enough to neutralize it. In areas where buffering capacity is low, acid rain releases aluminum from soils into lakes and streams. Aluminum is highly toxic to many species of aquatic organisms. Acid rain significantly impacts aquatic life by lowering the pH level of water bodies like lakes and streams, which can directly harm fish, amphibians, and other aquatic organisms, particularly affecting their reproductive cycles and causing population declines due to the increased toxicity of aluminum released from the soil into the water when it becomes acidic. This disruption can cascade through the entire food web, impacting even the organisms that feed on the affected species. In conclusion, acid rain poses a significant threat to aquatic ecosystems by altering the chemistry of water bodies, causing direct harm to aquatic organisms, and disrupting the delicate balance of the food web. Addressing the issue requires reducing emissions of sulfur and nitrogen oxides to minimize the impact on sensitive aquatic environments.